All right, welcome back. So this is an ALEKS topic that's called writing a chemical equation from a description of the reaction. This is a great topic to get us some practice converting, names into actual chemical formulas, writing chemical reactions, and then also balancing, making sure that we can balance our chemical reactions properly. So it's going to get started. I'm going to do 3 different examples of this topic in this video, so stick around. The first one says aqueous carbonic acid. So we want to pay attention to the word aqueous here. That's going to tell us what the phase label is for our different chemicals. Decomposes into liquid water and carbon dioxide gas. So when it says decomposes, it basically is meaning that this species here is going to turn into 2 other species. So what I would do to start is I would write H2CO3, aqueous, decomposes, it turns into liquid water. I know that water is H2O, liquid, so these phase labels are very important, plus carbon dioxide gas, that's CO2 gas. Now at this point, once you've written out your chemical reaction just based off of the words, you're going to want to make sure that it's balanced. So in this case, this one actually happens to be already balanced. On this side, I've got 2 hydrogens and 2 hydrogens, 1 carbon and 1 carbon, 3 total oxygens, 3 total oxygens. I've got my phase labels in there. So this one's done. That's all we need to do for this first one. Let's go ahead and do some more. So this next one says hydrogen gas and aqueous zinc chloride are produced. So that means that these are the products. So the term are produced, that means that these are the products. So these must be the reactants. By the reaction of solid zinc, so zinc solid, that's metallic solid zinc, and aqueous hydrochloric acid. So plus HCl, aqueous. So then those are going to react together to form these products. Hydrogen gas will be H2 gas plus aqueous zinc chloride. Now, we need to talk about zinc for a second here. In ALEKS, zinc has a +2 charge. I mean, not just in ALEKS, but zinc is going to commonly have a +2 charge. So even though it's not specified here, zinc 2 chloride, I know that, from my experience using ALEKS, that zinc is always going to have this 2+ charge. So zinc 2+, let's keep that in mind. So when I have zinc chloride, that means I must have zinc Cl2, and it's aqueous. And remember that it's zinc Cl2 because chloride is always going to have a -1 charge, right? It's in group 7. So for that ionic compound, I need to make sure that it balances out. So zinc Cl2, aqueous. Now I need to go through and make sure that it's balanced. So the way that I would, think about balancing this reaction, I would start with the zinc, and I'd say I've got 1 on this side, and I've got 1 on this side. That seems good. Hydrogen, I've got 1 on this side, but I have 2 on this side. So I'm going to need to put a 2 here to make sure that I've got the right number of hydrogens on both sides. So now 2 hydrogens here, 2 hydrogens here. That's good. Move on to chlorine, 2 chlorines, 2 chlorines. So now that that's balanced, that's all we need to do. So that's the second example. All right, one more example. So in this one, we've got solid sodium hydroxide decomposes. So this is going to be similar to the first one. NaOH, solid, decomposes into solid sodium oxide. So sodium oxide, again, we need to keep the charges in mind. That's going to be an ionic compound. Sodium has a +1 charge, oxygen has a 2- charge. So I'm going to need 2 of those sodiums for every 1 oxygen. Solid sodium oxide, so that's an S phase label, plus gaseous water, plus H2O gas. So here we've got H2O as a gas. Previously we had H2O as a liquid. So you really do have to pay attention to these phase labels, right? Just telling you what you should have in here. Now again, once we have our reactants and our products written out, we need to make sure that we balance the reaction. So the way that I would balance it, start it with the first one on the left-hand side. Sodium, 1 sodium here, 2 sodiums here. Definitely going to need to put a 2 here. Now, move on to oxygen. I've got 2 oxygens here. I've got 2 oxygens on this side. That works out. 2 hydrogens here, 2 hydrogens here. So this is all I need to do to balance this reaction, and that should be that. All right, hopefully that helps. Let me know if you've got any questions. Cheers.